Hey everybody, hope you're doing well. Welcome to the end of week 5 of the fourth marking period here in Algebra 2. This is the absolute last section of Unit 8. This is the 10th and final section, which we are going to talk about how to write power functions. This is very similar to what you did in the last section with writing exponential functions. You're going to see a lot of similarities as to how we solve it. There is one key difference, though, in terms of how the equation is written and set up and some of the math in between to get there. But there are some similarities you'll see in the steps we're going to take. So this note set here has 3 examples. We're going to talk through them here. Kind of the same thing as the last section. If you can do the first one, the other examples are exactly the same idea. One big difference you're going to see with this here is our answers are going to have a lot of decimals to them. It's very seldom that you'll get clean answers with these, and you can expect the same thing with if you're trying the extra practice problems, if you're trying the when you're doing the graded assignment, those sorts of things. So you're going to get some messy answers here. So again, follow the video here. I'm going to lay out the steps. If you want to try any of the examples after I show you the first one, hit pause, see if you get it to match, and if you do, you're probably in good shape. So let's talk about how to write a power function. Power function format is very similar to exponential function format. There's one key difference. If you compare them, it uses all the same variables, but you'll notice the x and the b are switched, okay? So a power function is in the form y equals a times x to the b power. Basically, we're going to find, like we did in the exponent section, exponential function writing section, we found a and b. We're going to do the same thing here, but you'll notice b in this case is an exponent rather than a base. So you see that reflected here as we go through the steps. All right, let's get into how to solve this here. So we're going to write a function y equals a times x to the b power. Graph passes through the points 3, 2, 6, 9. So we've got an x and y, and we're going to end up using both points here as we try to write this function. So I'm going to go ahead and use the first point 3, 2. And our very first step, very similar to what we did in the last section, we're going to go find, quote unquote, the a value. This is going to be like in the last section where we're not actually going to get a number for a right off the bat, but we're going to get something that will allow us to plug into the function and try to make some progress. So our formatting again for this, since it's a power function, y equals a times x to the b. I'm going to take that first point, 3, 2. 2 is the y. 3 is the x. Okay, so you can see how I've written that out here. Now, I'm going to try to quote-unquote find a. All I have to do to find a, so it's a times 3 to the b. If I want to move times 3 to the b power, I got to divide by 3 to the b power. That'll get me 2 over 3 to the b equals a. Again, we're not actually getting the a value just yet, but we're going to use it to help us find the b value, and then we'll go backwards and go find the a. Once we get the a by itself using that first point to kind of move some stuff around, now we're going to do step 2, where we're actually going to use it to go find the b value. So to do that, once again, here's my function, y equals a times x to the b. I'm going to take the other point, the 6, 9. 9 will go in for y, the 6 will go in for x. I now have something I can plug in from for a, based on what I did in the last step. So instead of just writing a, I'm going to use that 2 over 3 to the b power. Times, I have an x value from that second point of 6 to the b power. Again, the reason why we do it this way is if you look now at the problem, I now have an equation where I only have one variable. That's a good thing because then we can actually go solve for that variable. Now, how do we go about doing this correctly? So this mathematically, you have to pay very close attention to how you put all of your terms together. It's very easy to make a really stupid PEMDAS mistake here and screw this whole thing up. So what I'm going to show you here is the same formatting I'm going to do with all the other ones and what I encourage you to use as you do these on your own. You'll notice you've got 2 terms with a power of b. The 3b at the bottom of this fraction, 3 to the b, and this 6 to the b that you've got at the end here. What I can do is I can rewrite this. So that 2 is on top. What I'm going to do, because of how I can multiply fractions together, I'm going to put the things with the power of b on top of each other instead. Okay? It still means the exact same thing as what I had in the previous step. I'm just rearranging this a little because beauty of multiplication, I can rearrange things a little bit. Reason why I'm going to do this is because it's going to be a lot easier to see how I can condense this down. Exponent property. If I have the same exponent, that means I can combine them together with whatever operation the bases are doing. So what I can do here, since I have 6 to the b over 3 to the b, it is the same thing as having 6 over 3 to the b power. Okay? Basically, it's undoing power of a power, where if I distribute that b back in, it would look the exact same as the step above. All I'm doing here is condensing it, and you're going to see why. 6 over 3, okay, if this reduces, you should reduce it. Reduces down to 2 to the b power. This all of a sudden is a lot more solvable, okay, because now I've condensed it down into singular b rather having the b in 2 different spots. From here, the goal is to get b by itself. So I'm going to move this 2 that's right here, okay, I'm going to divide that away. So that'll get me 4.5, or you can leave it as 9/2. It's really up to you, but since this is a nice decimal, I'm just going to call it 4.5, equals 2 to the b power. Now, this would be a little bit easier, where this was easier when we did it with the exponents, was that the b was the base. That made it easy. We just undid the root that was there. Pretty easy math compared to what we've done this year. This now, since the b is the exponent, the only way we can solve for an exponent is to undo it using a logarithm. So again, this connects back to stuff that we've done in the early part of the chapter. So what I'm going to do, since the b is locked as an exponent, I'm going to go ahead and rewrite this as a log. So the base of my exponent problem is the base of my log. I put the value it's equal to after the log. It's then equal to the exponent, which in this case is b. By turning this from exponent form to logarithm form, again, that gets the exponent, the variable, by itself. Okay? That's the only way you can go about solving this step here. So it's definitely a lot of little steps to get there, but ultimately what ends up happening is you end up turning this into a log problem. So from here to solve it using your calculator, as we've talked about, you use that change of base formula using your calculator. So you type in log 4.5 divided by log 2. Remember, the base is always on the bottom, okay? It doesn't matter if the base is a bigger or smaller number, the base always goes on the bottom. So you type that in your calculator. Again, for accuracy, we're going to round to 3 places, excuse me. If you round correctly, 2.170 is your b value, okay? So, after all those steps, we found b. Cool. Now, step 3. Now that we found b, now we can actually go find a. I'm going to go back to step 1 where we had that expression for a. 2 over 3b equals a. I now know what b is. It's a gross decimal, but still, we now know it. 3 to the 2.170 power. Use your calculator, okay, do correct PEMDAS, however you need to punch it in. You're going to get a decimal, and a lot of times these are going to come out pretty small, and that's okay. You get what you get. If you punch it in correctly, you should get roughly 0.184 for the a value. You now have a, you now have b. Now comes the final step. Write the function. So again, this is the formatting of our function. Y equals a times x to the b power. I'm going to plug in the a value, 0.184, and the b value, x to the 2.170 power. And I've got the most beautiful looking function in the world with all of its decimals. Y equals 1.184x to the 2.170 power. Ta-da! That is how you write a power function. It is definitely tedious. It's very solvable. Okay, if you've been paying pretty close attention to what we've done in this chapter with how to convert between exponential and logarithmic form, it's just, again, tying all this stuff together in a bunch of different ways. This definitely takes some work, and I would highly suggest, as you're working through the graded assignment or any of these problems, I would definitely make sure you have this in front of you. We're going to use the exact same template for the other ones, and you're going to get these same gross looking answers. I highly suggest write this down or screenshot it or print or whatever you need to do. Have this in front of you so you can follow the template. Beauty of this is, again, you don't have to memorize how to do this for a test. You just simply have to show me that you can follow these steps a couple of times, okay? So, if you think you have a good gist of it, you want to try the next one, put it on a separate sheet of paper and see if you get it to match, great. Otherwise, watch me explain it. Again, I'm going to go through 2 more examples here. There's another example here on the next slide. So, we're going to do the same thing here in number 2. We're going to write another power function. I've got my 2 points, 2, 1, 7, 6. So again, step 1, we're going to find and the a value, we're going to get a by itself. And again, we're going to use the first point to do that. So here's my function. I'm going to plug the 1 in for y and the 2 in for x. To get that a value by itself, we divide away the 2 to the b power, because again, it's being multiplied to the a. So I would have an expression of 1 over 2 to the b power equals a. That'll help us for steps 2 and 3 as we move forward. Now comes the very long step 2, where we use all that information and the second point to go find b. So once again, when I go find the other variable, I'm going to use the other point, 7, 6. The 6 will go in for y. 1 over 2 to the b goes in for a. And the 7 goes in for the x. Okay, so now what we do here is we're going to rewrite this so that, reorganize the problem a little bit so that we got the b's over top of each other. Okay, because again, this is being multiplied. I'm able to do this. So the 1's going to come out front. Okay, I'm going to put the 7b over 2b instead. Means the exact same thing. Now, when I do that, again, I can rewrite this as 7 over 2 to the b power. Since they both have the same power, I can kind of condense it a little bit and just pull the power out front. I'm going to divide away that loose 1. Now we know 6 divided by 1 is 6, so that's nothing too fancy. So I have 6 equals 7 halves to the b power. The only thing I have left to do is to find that exponent. So now that I'm here, I'm going to turn exponential form into logarithmic form. So I'm going to have log of my base, which is 7 halves. If you want to turn 7 halves into 3.5, just so you don't screw it up in your calculator, be my guest. The 6 goes right after the log, and we set it equal to b. Because again, when you turn exponent into log, the log has to equal the original exponent that was there in the first place. So again, you go in your calculator, log 6 over log 7 halves, and again, you can turn 7 halves to 3.5. Divide that out, and what you will get is, we're going to check to make sure that I have the right values written down, is you get a b value of approximately 1.430. Okay? Now that we found b, let's go actually find a using the expression from number 1. So we had 1 over 2 to the b equals a. So 1 over 2 to the 1.430 is equal to a. Again, you're going to punch that in. It's not going to be a very large number. You're going to get 0.371 equals a. Your fourth step, you've got your b, you've got your a. Now we can write the function. So again, we write it, y equals a times x to the b. Y will equal 0.371 times x to the 1.430. And that is your final function. Same process. I'm going to show you one more example here. Again, I'll pull it up here in a second, or if you've got it in front of you, if you printed a note packet. Again, if you've seen a couple of these, try some parts of the third one. See how far you can get before you get stuck or realize that you need to look at this. And again, I highly suggest while you're doing your graded assignment, I would have this right in front of you. So make sure that you write it down, screenshot it, whatever you need to do to make this easy for you to complete. All right, last one, same idea. Another power function. The graph is going to pass through 3, 4, 6, 15. So again, step 1, let's find A. So we're going to find A by plugging in the first point. So our first point, once again, was 3, 4. So the 4 will go in for Y, and the 3 for X. We're going to get the A by itself, so we'll have an expression of 4 over 3B equals A. The very long step 2, now it's time to find B. So again, I plug in everything, including the second point and my expression for A. So my second point was 6, 15, so 15 is going to go in for Y. The A is 4 over 3B times 6 to the B. Now I'm going to rewrite this so that the B's are on top of each other. So I'll have the 4 out front. And then we'll put the B's over top, 6B over 3B. Now I can rewrite this as 6 over 3 to the B, rather than 6 to the B over 3 to the B. Again, if it can reduce, reduce it. So we'll reduce this down to 2 to the B power. Now we'll go ahead and divide away the 4. So that will give me 15 over 4, which again, if you want to leave that as a fraction, fine. I'm going to go ahead and write as a decimal here, 3.75 equals 2 to the B power. Once I've done this, now I'm going to go ahead and write it as a log expression because that's all I can do at this point. So again, my base is 2, so that's going to go right with the log. Right after the log is my other number, 3.75, and that'll equal the exponent, B. Using your change of base formula, this is what you'll enter in the calculator, log 3.75 over log 2. And again, you will punch it in just like that, and what you'll end up with, rounded to 3 places, B equals 1.907. Once you find B, now we go back to actually find A. So again, my expression from step 1 was 4 over 3B, 3 to the B, excuse me, equals A. So plug in the B values, your exponent, 3 to the 1.907. And then simply just punch it in and divide. You'll get an A value of approximately 0.492. You've got your A, you've got your B. I know this is a little bit more disorganized, which is funny because I have more space here. But last step here, write the function. So again, we go back to our original formatting, y equals ax to the b. Your final function would be y equals 0.492 times x to the 1.907 power. So, as tedious as that may seem, that's exactly how you write a power function. The one benefit of it is the exact same format every single time, and you have the benefit of having this right in front of you while trying a couple of problems here for some practice and for some credit here. So, I would highly suggest there's 4 practice problems on the quote-unquote homework. Maybe try 1 or 2 of those. Make sure you can make sense of it. If there's steps in here that you got lost on at any point, again, I would try to practice it. If that's not making any sense, get a hold of me here, and I'll be happy to go through and figure out what you're struggling with, because I know these take a little while, and these may not be the easiest for some of you. So, great assignment that goes with this. It's just like the last one, only 2 questions. Show me how to do this twice. Follow the steps, and again, I need to see work for it. I should not just see a final equation for it, though it'd be pretty, I think these are pretty impossible to do on Photomath, though I'm sure we can challenge me on that. But make sure that you are showing the work as I've shown here. If you can condense a couple steps, that's fine, but you should be following this template here to get your equations. So make sure you do that. Again, this is the end of Unit 8. We're going to move on to some different stuff here in these last handful of weeks. There's a couple more things that we need to go through and cover. I think they'll be a little bit easier than what you've been doing here. So if you've survived this, said this way before school let out, I would say this is the last quote-unquote super hard chapter. I think these last couple of things will go after what we'll be doing after this should be a little bit easier. At least that's what I think. So at any rate, if you have any questions, need any help, please don't hesitate. Get a hold of me. Send me a message on Schoology. Shoot me an email. Stop by during my office hours, please. Nobody ever comes by. Feel free to stop in. I can easily help you in live time. So that's pretty much it with that. If you need me for anything, please don't hesitate to reach out to me. Otherwise, thanks for watching. Stay safe, stay healthy, and we'll see you next time.